Alright, welcome. This is the 6.4 Ready, Set, Go homework solutions. The ready part, it says to define the polynomials and their attributes, okay? Just straight definitions. There's nothing complicated about this. A quadrilateral. A quadrilateral, in its name, quad, has four sides. The image is here. This is a rectangle. That looks like a other rectangle. No, not a rectangle, like a kite of some sort. And not kite, diamond, and this looks like a trapezoid. But again, a quad has four sides. A parallelogram. A parallelogram falls under a quadrilateral. It is a special type of quadrilateral. It has two parallel sides. So this, the top and the bottom, and the left and the right are all parallel to each other. Okay, so that is a parallelogram. A parallelogram falls under a quad. Okay, rectangle. A rectangle is a special type of parallelogram. In this case, it has again quad. It has four sides. Parallelogram. The left side and the right hand side are parallel. The top and the bottom are parallel. Also, it has four right triangles. Okay, that's what makes a rectangle unique. Okay, a square is part of a rectangle. How that is that again, it's like a quad, four sides, parallelogram, because the left side and the right side are parallel, top and bottom are parallel, 90 degrees, but also the values of the sides are the same as well. That's what makes it a square. A rhombus is like a square, but it's tilted to the side, so it's no longer 90 degrees. It's a whatever angle measurement it is. And a trapezoid would be a quadrilateral, right? Four sides, but parallelogram has two pairs of parallel sides. This only has one pair of parallel lines. Okay. All right. Good. Okay. So the next one. All right. I'm just gonna display this answer, and I can work the problem for you. Okay. All right. This is number 7. Okay. It asks us to do a couple of rotations above a fixed point of C. Right. I don't think you can sort of see it. Hopefully you can see it. Okay. I'm gonna do the problem in detail for you. Okay. All right. Give me a second when I set up Paint for you. Okay. Give me a second. I have to set up the Paint and we'll work on the problem. All right. Okay, so I have Paint up here. Okay, so you could see me do the problem in full. All right, so I'm gonna rotate. First of all, I'm gonna rotate P 90 degrees above the point C. Okay. All right, let's do that. All right. So here we notice that P is gonna go to C. How do we do that? Okay, so from the dot, do you see how it goes down one? Right, then it goes across 1, 2, 3, 4. Right, that's what I did. So if you want to see that numerically, it went down 1, then it went to the right 1, 1, 2, 3, 4. Okay, and again, it's a rotation clockwise 90 degrees. So it is we do the perpendicular for that. Let me show you. Okay, so right now it is right here, down 1, across 4. 1, 2, 3, 4. So we do that, but opposite, right? Opposite reciprocal. So you go up 4, 1, 2, 3, 4, then right 1. Okay. If you would like to see numerically what it is, this was your 4. Okay, this was your 4. Then it was your 1 to the side. Alright, that's if it was a 90-degree rotation, okay? And I could just fill it in here. But the question, this would be a 90 degrees, right? Because it's it's the perpendicular line here, okay? But it says we want it, we do want it at 90, and we want to call that P, alright? So we can call that P prime, because that is the first one, first transformation of the 90-degree rotation. And again, we want to do one more, so it's 180. So again, we apply the same procedure. We do the perpendicular slope again. So notice the perpendicular slope here was 1, 2, 3, 4, up 4, across 1, right? So same thing here, right? We are going to go to the right 4, 1, 2, 3, 4, then down 1, right? Do you see how this is a straight line? Okay. And if you would like to see, that was green. If you would like to see it, right, what I did, I went 4 to the right, then I went 1 down. Okay. And then there you go. That would be our new point. We'll call that P prime, P double prime, and that was from so from P to P prime 90 degrees, from P to P double prime it's 180 degrees, right? Do you see how the slope is the opposite reciprocal for the first reflection? Then it's also the opposite reciprocal again to get to the 90. Okay. I did it one more for the down here. I did it one more here for the 270. That's what you should see here at the solution. Okay, let me show you here. That's what I did here. Yep, there you go. That's how you can see this in detail. Okay, there you go. That's the first 90-degree rotation. That's the 180-degree rotation, and this is the 270 rotation. Okay. Number 8, I did it the same way. Okay, started at C. I wanted to go to P, so horizontally, right? I went up 5, across 3, then I apply that again, across 5, down 3. Okay, that would be 90 at P prime, then I do that again to get P double prime. Alright, if you would like for me to go in detail, just rewatch how I did 7. Okay, alright, let's look at 9. Okay, I'm going to do 9 from scratch so you could see me do the problem. Okay, give me a moment while I set up paint. Okay, paint's almost set up. Alright, so we have paint here. Alright, so the question asks us, what is the equation? This is number 9. What is the equation for the line of reflection that reflects P to P, P to P prime? Alright, let's look. We go from P to P prime, and it's a reflection, okay? Remember, one of the properties of reflection is that it has equidistance. So, let's count from P to P prime. 1, 2, 3, 4, 5, 6. There's a total of 6, okay? Then, remember, a reflection cuts, it has equidistance. So the whole thing here was 6, right? The whole thing here was 6. But if we want to break it up into 2 pieces, you have a 3 and you have a 3, right? And what goes down the middle is the line of reflection. So we would say here that the y-axis is the line of reflection from P onto P prime. Okay, write that up there. Now it says, what is the equation for a line that reflects the point P to P prime to P double prime? Alright, so we want P to P double prime. Again, there's equidistance from P to P prime and P double prime. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, alright, cutting it in half because again that's what reflection is. Alright, we also call it a bisector. Okay, alright, for here, then one more for here. Good. Alright, then we will cut it in half because the whole thing was 8, 4, 4, so the line of reflection is down that middle. So we would say here that the x-axis is the line of reflection from P prime to P double prime. Okay. Right, we would say that. Next, it says, can P double prime also be considered a rotation of P prime? P? Yes, it certainly looks like it can. Okay, let's just check. Okay, remember, a rotation has a perpendicular slope. So let's make that brown here. All right. So rotation P, and what is the center of rotation? Yeah, so let's see. One, two, looks like, yeah. Do you see how it goes down? 1, 2, 3, 4, then across 3. 1, 2, 3. Right? Okay. Yeah, right here. Do you see how it goes across 3, down 4? Same thing here. Down 4, across 3. Okay. Right? Do you see? 3 was here. This is 4. So yeah, this looks like, because the other one would be from here, right? So yeah, oops, sort of. It looks better like that. Yeah. Yes. So we would say yes, right? This would be your first 90. Then from here to here, that would be another 90. So from P to P double prime, it would be 180 degrees. So it would be a 100-degree clockwise rotation from P to P double prime. Okay. Okay. The important part here for you to understand, okay, right, is that if you reflect over the y-axis, then reflect over the x-axis, it is the same thing as a 180-degree rotation. Let me repeat, because again, that is very important. When you reflect over the y and reflect over the x, okay, if you compete A and B, reflect over the y, then reflect over the x. It is the same thing as 180-degree rotation. Okay? So that was the answer here, right? And that was 9. I think I showed a better answer here. Okay? So let me just replace that. This looks like it's a good answer. Okay? Let me replace 9 here. Right? So you can see it much better. Okay. Right. Pause the video if you would like to see 9 done in detail. Good. There you go. Alright. Okay. Let's do 10. Alright. Here's the answer for 10. I'm giving a second where I set up paint so I can do number 10 for you. Okay. In detail. Alright. Give me a moment. Still setting up the paint. Hang on. Just look at the solution right now while I set up paint. Alright, here we go. Alright, we are on paint now. Okay, so let's look. It says, what is the equation for a line that reflects from point P to P prime? Okay, so we are reflecting from P to P prime. Alright, remember, when it is reflecting, there is an equal distance. So there's a distance from P to P prime. Okay, what is that in half? Looks like half is right here at this point. Okay, because you see how it goes down 1 across 2, goes up 1 across 2. Looks like it's cutting down right here. So let's just cut that with this brown line here. Right, looks like that's cutting down straight the middle. Okay. There you go. Now we would like to just look at this equation, right? We would say that the slope here looks like it's going up 1 over 1, And the y-intercept, we would say the y-intercept is equal to 1. Right? That's what we would say. So we can write our equation now. Right? So the equation, right? So we would say here that the equation for the line reflection, right, is always in the format of y equals mx plus b, because it's a line and it's a linear line. So it's y equals mx plus b. So y equals m is the slope, which was 1, x plus the y-intercept, which is plus 1. There you go. Okay. Can I fit it in here or no? Or is it too much? Yeah, there you go. Okay, that would be your first one. Okay. Next, what is the equation of the line of reflection that reflects P to P double prime? So we went from P to P double prime, and it's asking for what is the equation of the line of reflection that reflects that. Okay, that's very straightforward because the distance from P to P double prime looks like it's just 1, 2, 3, 1, 2, 3. Yep, it's a perfect. Right? There's a distance of 3 here, right? And there's a distance of 3 here. So yeah. Alright, let me just cut this in half down the middle. And it looks like the equation here is y equals to 0. Because that is where y equals to 0, right? There's no slope, right? The slope is really 0x plus 0. But what's 0x? Right? So it's just y equals to 0. Right? Okay, that would be y equals to 0. Okay, it is the line of reflection for P onto for P prime onto P double prime. Okay, there you go. Let me just write that there. There you go. Last one. Can P double prime be considered a rotation of point P? If so, what is the center of rotation? How many degrees? Is P double prime considered to be a rotation of P? A rotation of P. Okay, hold on. Give me a second here. All right. So I would say that it would be a rotation from P double prime to P prime to P double prime would be considered a rotation, because here you see how it's 3 3 and it goes identically. But can P double prime be a rotation of P prime? No, it would not be, because there's no way you can extend this. It's too far out. Right? It's too far out here. Let's see. Maybe there is. Okay. Let me grab right. Here's your answer for A and B. I want to grab a fresh question 10. Okay, and we'll see if there's actually a reflection or not. A rotation. There shouldn't be. But let's just play around a little bit. Right? The video might go a little bit longer because I want to experiment this to show you. Trial and error, right? That's how you learn. I don't memorize anything, right? You have to think through the problem. Okay? So, alright, let's go from P to P double prime. Alright, so if it's a rotation, there's only one rotation that looks like this, right? Okay, it looks like it's 180 degrees, okay? Because if it's 90, it should be somewhere here, right? So this should be 180 somehow, okay? If it's 180, okay, there needs to be a perpendicular slope somewhere, okay? So let's see. 1, 2, 3, 4. Does this work? 1, 2, 3, 4. Ooh, it might work. 4. 4. Ooh, looks like it does work. 1, 2. Good. 1, 2. Oh, it does work. That's a distance of 2. That's a distance of 2 here as well. Alright. Yeah, it does work. This would have to be the center of rotation then. Right here. This would be from P to P double prime. This would be the center of rotation. So we would say right here, let's just make purple. Okay. P can be rotated onto P double prime with a 180-degree rotation clockwise, with the center of rotation at the point, what is that? 1, 2, 3, 3, 1. So 3, comma 1. Alright. So here you go. Let me make that red so it stands out for you. Okay, there you go. Okay, all we did here is we knew that it had to have a line connecting them. If it's a 180-degree rotation, then we find the perpendicular slope, right, by matching up just right triangles. Perfect. Elegant. That's a great answer. That's a really great answer right here for 10. Right? Okay. This is from P prime to P double prime. Okay. Let me just give you the answer here for that. Okay. Oop. Right. 10, 11. Again, what I did is I 11 here from P to P double prime. I did the same thing. Okay. Look at number 10 if you would like a detailed explanation. Right here, it went off a little bit. So the line of reflection was a decimal. Okay, but same procedure here. From P, could P double prime go from, I know it could have been a rotation from P prime to P double prime. Alright, but can P double prime also be considered a rotation of point P? If so, what is the center of rotation? Alright, so let's grab a clean number 11 and see if that's possible. It should not be possible. Okay? It should not be possible. Read the question again one more time, because it says that P prime, can P double prime be made from a rotation of P prime, of P? So can you go from here, from P to P double prime? A rotation? Does not look like a rotation. Look. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's no rotation here. Right? It wouldn't rotate. Right? Can it? Hold on. Hold on. Let me draw a line straight down here. So this was 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So half of 9 would be 4.5, right? So we want a distance of 4.5, and we want, on the other side, we also want a distance of 4.5, right? Okay. So 1, 2, 3, 4, half right there. All right. So 1, 2, 3, 4 and a half. Ah, it is possible. Look. Thinking about it, I thought it was impossible because this looks like a reflection. It really does. Because when it's mirrored like this, it just looks like a reflection of right here. This would be the vertical line that point P is reflected to make point P double prime. But are you saying, can it be a rotation? It actually does. Because look. it looks like it went here. It looks like it went. Let me draw right here. It looks like it. Oops. Let's make that green for you here, because it looks like it went from here to here with 90 degrees clockwise, right? Then it went again at 90 degrees clockwise. So again, you went 90 degrees clockwise. So yeah, yes, we would say C would be correct. It is. Yes, so we would say yes, P can be rotated, uh, rotated onto P double prime by a 100-degree clockwise rotation. Okay, there you go. That would be your valid answer for 11. I thought looking at it wouldn't be, but again, okay, make sure you do the problem. All right, sometimes your intuition can be wrong. Okay, good. All right, and this I just did a problem from P prime to P double prime. I could say that was a rotation as well. All right, the center of rotation was right there. Okay, all right, let's look at the go part. Okay, the go part here asks us to rotate these coordinates, and you could actually use the reference, right? This is rotate because you're rotating above 0, 0, which is the origin. If you start at the point AB, you can follow this rule. Okay, this works. Okay, from A, B, right? If you follow this rule, it would work. Okay, here is the answer already. Okay, let me make it smaller so you can see the grid. Okay, there you go. Okay, I'm going to do the problem from scratch so you can see it. Okay, so give me a second while I set it up on in Paint, and then we'll go from there. Again, pause the video if you would like to um, see it done. All right, good. Okay, so here I have Paint. All right, good. And I think I'm going to bring up the coordinates here, right? So the first one looks like it said, the first one said go from A for 4, 2, right? Where's 4, 2? Let's look at that. Okay, which was point A. We'll make that black. Put that in. All right, let's do that from 4, 1, 2, 3, 4, right? And up to 1, 2. So this is the point A of 4, comma 2. Good. They say you want to rotate this 180 degrees. Very straightforward. We apply our rule of perpendicular lines. Okay. Alright, so from here, right, because again, we're rotating it above 0, 0. So it goes from here to 0. How do we do that? Let's do that. 1, 2, 3, 4. It went horizontally 4, then it went down 2. Good. So if it's a 180 degrees, right, it goes from 1, 2, 3, 4, 1, 2, right? That would how it would look like if it's 90. But we apply this one more time because we want it 180. So 1, 2, right from here, 1, 2, 3, 4, 1, 2. There you go. And we can fill that in. Right here. That would be a double prime, and that's the point 1, 2, 3, 4, negative 4, and negative 2, right? All right, let's see. And if you look at the solution here, right, notice that if you go from A to A double prime, the sign changes. So this is all negatives. Okay, good. Let's do the next one. Okay, B. We are going from -5 comma -5 comma -3. So let's do that. -5. So 1 2 3 4 5. -3. 1 2 3. Right. This would be your point. B is -5 comma -3, and we want to rotate this 90 degrees clockwise, right? Okay. So again, perpendicular line. 1 2 3. 1 2 3 4 5. Right. So we are gonna go clockwise. So right. So right, this was 1 2 3. 1 2 3 4 5. So 1 2 3 4 5. 1 2 3. Right, perpendicular slope. Okay. Right, clockwise. There you go. That would be your 90 degrees. Up 3 across 5, so it's down 5 across 3. Right, perpendicular slope. Make sure you're flipping the fraction. Right, and we call that the perpendicular slope, which is going to be B prime, and that is the point 3 comma -5. Right. Again, if you want to use the cheat sheet, notice this is only going from A, B, positive into here. Okay, you can't memorize the chart right here for the cheat sheet if you're going from this negative to here. Right, You want to just, the perpendicular idea is more elegant in nature. Right, it can just make your life easier than just memorizing this. Okay, understand the perpendicular slope. It's going to help you so much easier. Okay, right, so there you go. That was where B prime is after the 90-degree rotation. Okay, all right, let's do the next one. C. C is at -7 comma -3. Right, so let's do that. So -7, 1 2 3 4 5 6 7, and +3, 1 2 3. Right, this was your C, which was -7 comma 3. Okay, and we want to rotate this 180 degrees. All right, let's do that. All right, again, rotation is always your perpendicular line. We went down 1 2 3, across 1 2 3 4 5 6 7. All right, so again, I'm going to apply that rule. It was down 7 across 3, so up 7. 1 2 3 4 5 6 7, across 3. 1 2 3. This is true if it was a 90-degree rotation and we were going clockwise, right? So again, repeat this again. So it was up 1 2 3 4 5 6 7, across 3. So it's going to go 1 2 3 4 5 6 7. 1 2 3 4 5 6 7, across 3, 1 down 3, 1 2 3. Right, perfect straight line. All right, make the dot. Okay, this is C prime. We call this 1 2 3 4 5 6 7. That is at the point 7 comma -3. Okay, that is C prime for you. And D, let's do the last one. Okay, and D is at 1 comma -6. So 1 -6, 1 2 3 4 5 6 1 6. Good. This is the point. That's the point. D is 1 comma -6. Okay. We are rotating it above the center, so let's do the line. So went across 1, 1 2 3 4 5 6. So went left 6, no, left 1, up 6. 1 2 3 4 5 6. Okay. We want to do a 90-degree rotation, so again we apply that same rule. I think we went right 6 1 2 2 3 4 5 6, and up 1. Right. You see, you went left 1, so up 1. Right, perpendicular slope. Okay. I'll put your dot. Right, and we call that d prime, and that is at the point 1, 2, 3, 4, 5, 6, 1. Okay, good. So there you go. Those are all your solutions for your 6-1 ready, set, go. Okay, all right. Memorize, if you want to memorize the cheat sheet for the rotation, go ahead. Right? I never memorized it. Everything should just come from this understanding of perpendicular lines. Okay? All right, there you go. Those are all your solutions for the 6.4.